myself Janil Popat. I welcome you all. Let us understand numericals of the chapter Consolidation. In previous two videos, we have understood theory portion of consolidation. Let us go to numericals now. Let us start. We are going to use Tarzagi's equations as well as consolidation settlement equations in the numericals. Let us start the session. First problem, in a laboratory consolidation test on a 20 mm thick sample of saturated clay taken from a site at 50% consolidation point was reached in 10 minutes. So 50% consolidation in 10 minutes with double drainage. Estimate the time required for the clay layer of 5-meter thickness at the site for 50% consolidation. So we have to find out at site when it will occur. If there is drainage only towards the top, so drainage is single drainage because it is given as only towards the top only. Okay, how much time is required for the clay layer to reach 90% consolidation? So there is another question. And what is the time required for the clay layer to reach 50% consolidation if the layer was double drainage instead of single drainage? Let us solve the problem. So degree of consolidation in the laboratory and in the field is same, so it is 50%. Now it is a case of, in first case there is D1, that is a double drainage, so 20 by 2, that is 10 mm, is equal to 1 centimeter, and D2, in this case it was single drainage condition, so we can take D2 is equal to 5 meter and 500 centimeters. Now time taken in the first case, that is T1 is equal to 10 minutes and T2 is to be found out. Let us find T2. We know T2 by T1 is equal to D2 by D1 square. Now we are having values of T1, D2 and D1. So let us put the values in this equation. I am getting my answers as 25 lakh minutes. Now let us convert it into days and then years. So by converting it into days by dividing 24 and 60, it comes as 36 days and it is approximately 4.76 years. So the first answer is 4.76 years. Let us go to the second question. In the laboratory, degree of consolidation was 50%. So it is lesser than 60%. So we have to use formula for time factor, that is pi by 4 into u by 100 whole square. Here u is given as 50%, so we can find out time factor as putting all the values in the equation. Time factor will be 0.1963. Let us move forward. Now we can find out value of CV as coefficient of consolidation, as we are having TV, D and TE. Now putting the value of TV as 0.1963, D is equal to 1 centimeter and T is equal to 10 minutes, as in the first case it was. Now value comes as 0.01963 centimeter square per minute, as we have put time in minutes. So we got CV value. Let us move further. On field, D is equal to given as 5 meter is equal to 500 centimeter and degree of consolidation on field was 90%, which is greater than 60%. So I cannot use this formula. I have to use another one for time factor, which is 1.7813 minus 0.933 log 10 base 100 minus u. Here degree of consolidation is 90%. So putting that value, I am getting time factor as 0.848. Now moving forward to time period. TV into D square by CV. I am putting the values from above values, like 0.848 from TV, D is given in the field as 500 centimeter and CV as found out as 0.01963. Let us put the value of T in minutes like this, and in days 7500 days. Converting it into years, it is coming 20.54 years. So The second answer is 20.54 years. Let us move forward to the third question. So we have to find out time required with 50% consolidation with double drainage. Let us find out. So as we are given double drainage, in the case of double drainage, we do take depth as half of the given depth. Let us move forward. T2 by D1 is equal to D2 by D1 whole square. Let us move to the values. Now D2 will be put as half of 500, so it is 25 250 centimeters. Let us move forward, putting all the values in T1, D2 and D1. I am getting the value as 6,25,000 minutes. Converting into days, it is coming as 434 days and 1.19 years. So the third answer is 1.19 years. So for double drainage, it will take lesser time than single drainage. Let us move forward. Problem number 2. In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kilonewton per meter square, it got changed to 0.994 when the pressure was increased to 429 kilonewton per meter square. So do concentrate here. Here pressure is increased and void ratio got decreased. Calculate the coefficient of compressibility, compression index and the coefficient of volume compressibility. Find the settlement of the foundation resting on above this type of clay. If thickness of the layer is 8 meter and increase in pressure is 10 kilonewton per meter square. Let us not complicate the problem and write given data. E0 initial void ratio is given as 1.068. Final void ratio E is given as 0.994. As well as we can find out delta E, that is difference in void ratio. The difference in void ratio comes out as 0.074. Now another thing are given that sigma 0 dash initial effective pressure, that is 214 kilonewton per meter square, and then it got increased up to sigma dash, that is 429 kilonewton per meter square. So we can find out delta sigma dash, that comes out as 215 kilonewton per meter square. Let us move forward and calculate the given things. First of all, coefficient of compressibility. We know the formula for AV, that is E0 minus E, or we can say delta E by delta sigma dash. We found out delta E and delta sigma dash. So let us put the values and get the answer for AV. Putting values of delta E as 0.074 and delta sigma dash as 215. AV is coming out as 3.442 into 10 raised to minus 4 meter square by kilonewton. So unit of AV should be in meter square per force or kilonewton or newton. Let us move forward to compression index. We know the formula for compression index CC is E0 minus E upon log 10 base sigma dash upon sigma 0 dash. So putting values of E0, E, sigma dash and sigma 0 dash, 0.074 and 429 and 214. The answer is coming out as 0.245. These formulas are learned in previous videos already, so we are not discussing in depth here. Let us move forward to coefficient of volume compressibility. For volume compressibility, we can get the formula mv is equal to AV upon 1 plus E0. Formulas of mv are various, so we can use according to problems asked in the exams. Let us write out the value of AV and E0. AV value is 3.442 into 10 raised to minus 4 and E0 is 1.068 given in the problem. So let us move forward. MV answer is coming out as 1.664 into 10 raised to minus 4 meter square by kilonewton. Let us move forward. Settlement of foundation. The last thing was asked in the problem, that is settlement of foundation. Let us find out with this formula. SC is equal to CC into H by 1 plus E0 into log 10 base sigma 0 dash plus delta sigma dash upon sigma 0 dash. Putting values of cc as 0.245, h as 8 meter given in the problem, E0 as 1.068, log 10 base, sigma 0 dash as 214, increase in effective pressure that is given as 10. So give your attention here. Here we should put the value of 10 and 214. The answer we are getting, that is 0.188 meters. Now converting into mm, answer is coming out as 18.8 mm. So this is the answers for problem number 2. Let us move forward to next problem. A clay layer 8 mm thick, thickness of layer is 8 mm, is subjected to a pressure of 70 kilonewton per meter square. If the layer has a double drainage, do mark that it is in double drainage situation, and undergoes 50% consolidation, and TV is coming out as 0.196 in 1 year. So here time period is given, TV is given, and U percentage is given. So determine the coefficient of consolidation. If coefficient of permeability is 0.04 meter per year, determine the settlement in 1 year. And gamma W should be taken as 9.81 kilonewton per meter cube. Let us solve the problem. First of all, it is given as double drainage. So we have to take h by 2 here. We should know that. Now h is given as 8 meter thick. Here 8 mm is written, but it is 8 meter. So 8 by 2 is equal to 4 meter. So this is the average depth of drain. So D is equal to 4 meter. Let us move forward. U is given as 50% and TV is given as 0.196 in the problem. So putting TV, D and time period value, we can get CV. CV is coming out as 3.136 meter square per year. Now moving forward to further, K is equal to CV into MV into gamma W. We know this formula very well from theory videos. Now for MV we can put K value, CV value as well as gamma W value. K value is 0.04 as well as CV value is 3.136 and gamma W is given as 9.81. Now MV answer is getting 1.3 into 10 raised to minus 3 meter square by kilonewton. Do note the unit of MV. It is meter square by kilonewton. If you are getting different unit in the exam, you can know that the formula used for that, it is wrong. Let us move forward. SC is equal to MV into H into delta sigma dash. From here we can find out SC. SC is settlement of soil. Now MV is coming out as 1.3 into 10 raised to minus 3. H is given as 8 meter and delta sigma dash is 70. So putting all the values, total settlement comes out as 0.728 meter. Let us move forward and find consolidation in 1 year. Now settlement in 1 year will be 50% of total settlement, and doing 50% of 0.728, it is coming out as 0.364 meter. So that's it, and here I conclude this chapter. We will learn next chapter in next video. Thank you.